Systems of Equations A3. Today we'll be focusing on the matrices. Please make sure that you refer to the vocabulary. It will be useful in understanding the notes that will follow. Okay. In determining the dimensions of a matrix, you simply count the number of rows and the number of columns. Therefore, the dimensions of this matrix are a 2 by 3. When looking for the address of values within a matrix, please refer to this table at the left. You can adjust that for any matrix you want to. The first number is the row. The second number is the column that the number is located in. Therefore, the address for number 8 will be located at A23. And A signifies the name of the matrix. 2, 3 represents the number of row and column that the number is located in. The dimensions of this matrix are a 3 by 3. The address of the value -3 is located at M2, 1. We're looking for the entry that is located in M32, so that's 3, 2, which is the value 2. Matrices love structure, and as long as you see the structure, you will do just fine. Alright, adding and subtracting matrices. Please make sure that you understand that in order to add and subtract matrices, the dimensions of the matrices must be identical. Okay? So in looking at this list of possible examples, A and C, that's this and this, have identical dimensions. They can be added or subtracted. D and B have identical dimensions. They can be added or subtracted. A and D do not have identical dimensions, therefore they cannot be added or subtracted. Therefore, what you have is a dimension mismatch. I use this terminology because this is the terminology your calculator will use if in fact you try to do this incorrectly. Alright, going back to the two that you can. You simply add the numbers that are in the same address number or address of the different matrices. 7 and 1, -2 and 8, 8 and 4, and -4 and -3. The solution matrix is the sum of each of those numbers, 8, 6, 12, and -7, and I'm technically going in the wrong order. You go across the row, then to the next, across to each column, and then down to the next row. Just make sure you keep that in mind. Okay, subtraction is no different. So you subtract the digits in each one. Because D is first, we'll put all of the digits in D first and follow that up with B. Now remember, a negative and a negative is a positive. -4 minus 4, -4 minus 5, 7 minus 1, -2 minus -1, and 3 minus 2. 3, 0, -9, 6, -1, and 1. The question is the matrix addition and subtraction commutative? Well, let's take a look. If I switch the position of each one of these, therefore adding C plus A, will I get different values? The answer to that question is no. So, in addition, adding matrices is commutative? Yes. Now let's take the same example here. If I go ahead and switch the position of each one of these values, will I get the same number in the solution matrix? The answer to that question is no. So, in adding and subtracting matrices, addition is commutative, subtraction is not. Alright, we're going to take a look at examples now where you're using a scalar to change the dimensions or the addresses inside of a matrix. Okay, this is no different than using the distributive property. Okay, the distributive property states that I'll distribute this 1/2 to all of the numbers inside the matrix. So in essence, it is 7 times 1/2, 8 times 1/2, -2 times 1/2, and -4 times 1/2. That gives me 7/2. That gives me 4. That gives me -1 and -2. Okay, now we're going to use that idea to help add and subtract these values, or these new matrices here, adding in a scalar on each of these answer choices, A and B. First thing we need to know is that A and C are actually the same dimensions. So A works out. C and D. C and D, the dimensions are not the same, therefore you will have a dimension mismatch. Alright, 2 times A minus C looks like this. So first thing I'm going to do is I'm going to multiply 2 times all of the values inside of matrix A. Then I will go ahead and subtract those from the numbers in matrix C. And it looks like this. 4 minus 1, -4 minus -2, 6 minus -2, 0 minus 5, 4 minus 0, and 2 minus -4. The solution matrix is 3, 3, 8, 4, -2, -5, and 6. Alright, please complete C before moving on in the video. Once you have completed it, check your work against mine. Alright, moving on. Solving for missing variables is pretty straightforward. Notice we're using addition, therefore this number plus this number is going to equal that number. So 3 plus x equals -2, x equals -5. Likewise, this number plus this number equals y, so 2 plus 4 equals y, y equals 6. Okay? Matrix multiplication is what we will be studying next. Please take a few minutes to familiarize yourself with this before moving on. Alright, here, example number 6. Notice that you have a 2 by 2 matrix and a 2 by 3 matrix. Okay? A times B is possible because the numbers on the inside are identical. Okay? Therefore, the matrix that you will get as a solution matrix is a 2 by 3 matrix. Okay? Looking at it the other way, it's the 2 by 3 and the 2 by 2. That's B and that's A. The numbers on the inside do not match up, so no, it is not possible to multiply those. matrix multiplication commutative, this example proves that that is not the case. Okay? When using matrix multiplication, you want to multiply the first row by the first column, the first row by the second column, the second row by the first column, and the second row by the second column. That is what this indicates right here. Filling in all of the blanks here, you'll notice that you have 4 and 4, 4 and negative 1, 7 and 6, 8 and negative 1, 2 and 6, 5 and negative 3, and 5 and negative 3. Multiply B times A if possible. Okay, so the matrices are identical, a 2 by 2. Therefore, it is possible because the numbers on the inside match identically. So, what I will get is negative 1 times 4 plus 5 times 8. 6 times 4 plus negative 3 times 8. Negative 1 times 7 plus 5 times 2. 6 times 7 plus negative 3 times 2. The solution matrix here is going to be 36, 3, 0, and 36. Okay? In example number 8. Multiply if possible. Notice that you have a 3 by 2 and a 3 by 3. Please work example number 8 prior to moving on and check your answers compared to the ones I got.